I hope you're good, guys. We're doing the first part of calculus. I'm just introducing it to you so that you can have the overview of what's going on here. But I'm going to show you the very important things that you must know that are actually found on question paper. So we're doing cubic functions, and we have a general formula for all cubic functions. So we have ax, not for all cubic functions, but for all functions, we have ax cubed plus bx squared plus cx plus d. Then we know that the a tells us about what? The gradient, or a is the gradient, the slope of a graph. Then d is the y-intercept, where the graph is cutting the y-axis of the Cartesian plane. Then if a is greater than 0, it means a is positive. This is how you must actually remember it. The graph starts by increasing, then it ends by increasing. And if a is less than 0, it means the graph will start by decreasing and it ends by decreasing, as you can see. But I'm going to show you that using different color of the ink. Okay, let's actually start here. Here, as you can see, the graph is increasing. When the graph starts by increasing, it means that a is positive. I'm not sure if you understand that. So it is increasing, but when it gets here, it doesn't increase or decrease. So this point here where the graph doesn't increase nor decrease, it is known as what? As the stationary point. Those that are doing technical maths, they call it critical point or stationary points, as we know. Then the graph starts to decrease here. Remember, when the graph starts by increasing, it means a is positive. Then it ends by increasing. So this point here, it is also known as the stationary point, or a turning point, or critical point. Stationary point, where the graph is not increasing nor decreasing. Then it continues. Remember, we said if the graph starts by increasing and ends by increasing, it means that the value of a is positive, the gradient, the slope of the graph is positive. I hope you understand that. And if you can come here, it starts by decreasing. It means a is negative. That's very important. Then this point here is known as what? As a stationary point. That's very, very important for you to know. Where the graph is turning, it is known as the stationary point. Then it increases. Then when it gets to this point over here, it is not decreasing or increasing. It is known as what? As a stationary point. I hope you are following. Then it ends by what? By decreasing. So it started by decreasing and it ends by decreasing, meaning the graph is the gradient is negative. Okay, now as you know now that the graph here is increasing, it means that the gradient, I'll use m, even if you use a to understand the same thing, the gradient is positive. That's very important, or a is positive. But when the graph decreases, I just want to show you where the graph is decreasing here. It means that the graph is negative. The gradient of the graph there is negative where the graph decreases. I hope you understand that. Decrease, negative. Increase, positive. I hope that makes sense. But exactly in our stationary point, the graph is 0. Why? Because it is not increasing or decreasing. I hope that makes sense. It is 0. It is in its equilibrium. Then even here, gradient is 0. I hope it makes sense. Okay. And another important thing that you must note is that this part here, since the graph is increasing, they might ask you the question that says, for which values of x is the graph increasing? Or for which values of x is the graph increasing? Yes, what you must do, you say first derivative you derive the graph of f. If it's f greater than 0, then you solve for x. That value will be the value of x where the graph is increasing. So for a stationary point, for you to find the stationary point when you are given the formula or the graph, say first derivative equals 0, then you solve for the x values of the stationary points. Then you will take those values of the stationary points after deriving, you substitute them on the original graph so that you can find the y corresponding value. Then when they say the graph, or when they say the graph decreases, or for which values of the graph, for which values of x is the graph of f decreasing, you say first derivative less than 0. I hope that makes sense. So whenever you're asked to find stationary points, first derivative equals 0, you solve for x. Alright, so these are also stationary points, all of them. You derive, you solve for x values, then you take those, you take those x values, substitute them on the original, not on the derivative. Then you find the y corresponding values of the stationary point. Then there's this point over here. It is known as the point of inflection. Point of inflection. It's like it is separating the graph into two parts. What you must do, second derivative, you equate it to 0, solve for x. Then that x value that you got, you will substitute it on the original graph to find the y corresponding value. Or the second method, let's say you're given coordinates here, you're going to use that x and this x here, meaning you must add the x values of the turning point or stationary points, then you divide them by 2. Then after dividing by 2, you take that x value, substitute it on the graph of f or on the original graph to find the y corresponding value. I hope that makes sense. So it's very, very important, guys. Very important. So what I can say now is that for you to find the stationary point, I repeat, you derive the graph of f. If it's the graph of f, then you equate it to 0. After equating it to 0, you solve for x values. Those x values, substitute them on the original graph to find the corresponding y value. I hope that makes sense. If it does, please like the video. And if you do not understand, make sure that you rewind the video. Now there are these questions they will ask you for which values of x, or yes, for which values of x is the graph of f. Is f concave up or concave down? Okay, let's start with concave down, concave up. They want to know the values of x where the graph is concave down or concave up. What you must do, second derivative less than 0. Down is less, right? You solve for x. Then that value of x is your answer. If they want the values of x for which f is concave up, second derivative greater than, so up is greater than 0, then you solve for x. I hope that makes sense. So it's very, very important, guys, for you to know that. So if they want you to solve when they say the graph decreases, first derivative less than 0, increases, first derivative greater than 0, what else? Point of inflection, second derivative equals 0, solve for x. Then you take the x value, you substitute it on the original graph. I hope it makes sense. Or you can take the x values of the stationary point, you add them, then you divide them by 2, then you will take that answer as it is the value of x and substitute it on the original graph to find the y corresponding value of the point of inflection.